Welcome to this lesson on machine learning. While you do not need these definitions to use artificial intelligence systems like ChatGPT, understanding how AI works could greatly enhance your overall comprehension of AI and advanced engagement with such systems. We will start by introducing the fundamental concepts and principles of machine learning. Machine learning, ML, is a subset of artificial intelligence that involves the use of algorithms and statistical models to perform tasks without explicit programming. Core principles include concepts such as training and testing data, overfitting and underfitting, bias-variance trade-off, and the general process of model selection and evaluation. Supervised learning. In supervised learning, we have a set of labeled training data. Each instance in the training set contains the input features and the corresponding correct output, or label. The goal of supervised learning is to train a model that, given the input features, can accurately predict the output. This can be used for classification problems, where the output is a category, like spam or not spam, or regression problems, where the output is a continuous value, like house price. Unsupervised learning. Unsupervised learning involves training on data that has not been labeled. The machine learning algorithm tries to learn the underlying structure of the data, or to summarize it in some way. This can include clustering, grouping similar instances together, anomaly detection, finding unusual instances, and dimensionality reduction, simplifying the data without losing too much information. Reinforcement learning. In reinforcement learning, an agent learns how to behave in an environment by performing actions and getting rewards or penalties in return. The goal is to develop a policy, which is a strategy that defines what action the agent should take under certain circumstances. Reinforcement learning is particularly useful for problems where there is a sequence of decisions to be made, like a game of chess. Reinforcement learning algorithms. Markov decision processes, MDPs, are a mathematical framework for modeling decision-making problems in an uncertain environment. An MDP is defined by a set of states, a set of actions, a transition function, a reward function, and a discount factor. The state of an MDP represents the current situation of the agent. The actions available to the agent are the things that the agent can do to change its state. The transition function describes how the state of the MDP changes when the agent takes an action. The reward function describes how much reward the agent receives when it enters a particular state. The discount factor determines how much weight is given to future rewards. Q-learning is a reinforcement learning algorithm that learns to map states to actions that maximize expected reward. Q-learning works by iteratively updating a table that stores the expected reward for taking each action in each state. The table is updated using the Bellman equation, which is a recursive equation that describes the relationship between the expected reward for taking an action in a state and the expected reward for taking an action in a subsequent state. Policy gradients is a reinforcement learning algorithm that learns to map states to probabilities of taking actions. Policy gradients work by iteratively updating a policy function that maps states to probabilities of taking actions. The policy function is updated using the policy gradient theorem, which is a theorem that describes how the expected reward for a policy can be improved by changing the policy function. Different machine learning algorithms. This refers to exploring a variety of algorithms used in machine learning, beyond the broad categories of supervised, unsupervised, and reinforcement learning. This could include specific algorithms like decision trees, neural networks, support vector machines, etc. Each algorithm has its strengths and weaknesses and is suitable for different types of tasks. Application of machine learning to real-world problems. Machine learning can be used to solve a wide range of real-world problems. This could include anything from predicting stock prices, recommending products to customers, detecting fraudulent transactions, to driving autonomous vehicles. The key is to identify a problem where machine learning can be effectively applied, to prepare the data correctly, to choose the right algorithm, and to tune it for optimal performance.